In our previous video, we have explored the introduction to calculus, and today we will be discovering a fundamental topic in calculus, limits. As we know, calculus is used for studying precise changes. How would you define a change? Let us use a simple analogy. Imagine you drive a car from rest along a distance of 30 km within 30 minutes. Now, if I ask you what was the speed of the car, you would probably pull out the classic S equals to d by t equation and say that the speed of the car was 1 km per minute. But do you think that the speed of the car was absolutely constant? Well, this equation isn't really correct, it's just an approximation. Even at the highest possible precise machines, it's impossible to reach perfectly constant speed, because there always can be an infinitesimally small change. And so to study precise changes, we must calculate the distance covered in this amount of time. Now the concept of limits is that we allow h to move as closer to 0 as close it can, but we limit h from becoming 0, as simple as that. Now this concept is also applicable for functions. We can limit a function's input value from approaching a point for studying how it behaves when it becomes arbitrarily close to a point. We use limits to avoid division by 0 or getting undefined values. This has allowed us to study precise changes. Now that we can mathematically handle the constant, we can study precise changes and calculate derivatives. We will talk about this in our next videos. Now let's continue with limits. We write limits like this, which is read as limit of x as x approaches a f of x, where lim stands for limits. X is the variable we are limiting, a is the point where we don't want x to go, and f of x is the function. Now let's dive deeper. Limits follow certain rules. Some of them are the sum rule. The limit of the sum of two functions is the sum of their limits. The difference rule. The limit of the difference of two functions is the difference of their limits. Product rule. The limit of a product of two functions is the product of their limits. Constant multiple rule. The limit of a constant times a function is the constant times the limit of the function. The quotient rule. The limit of a quotient of two functions is the quotient of their limits, provided the limit of the denominator is not 0. Now, how do we calculate limits? That's a good question. Let's see. There are certain rules for solving limits. If the function is a polynomial, then limit of x as x approaches a f of x is just f of a. Simple. Now let's do a sample question. Limit of x tends to 0 f of x equals to x square plus 2x plus 1. In this case, it's a simple limit of a quadratic function. We can simply find the value of the function at 0, which is 0 square plus 2 into 0 plus 1, which is 1, and it's your answer. Now what about the functions in rational form? Let's work out on such a function. Let's say that f of x equals to 2x square plus 3x plus 1 by 3x square minus 2x plus 1. Now let us find the limit of this function as x approaches 0. We get 1. It's simple because we can use substitution in this case. Now let's see another function. F of x equals to x square minus 4 by x minus 2. This seems simple, right? Let us find the limit of this function as x approaches 2. You try to use substitution in this case, but you get a 0 by 0. You see, it's 0 by 0, that's undefined, right? What we do in this case? These types of limits are called indeterminate limits. There are certain forms of indeterminate limits such as 0 by 0, infinity by infinity, 0 raised to the power infinity, and etc. But in this video, we will talk about only the 0 by 0 form. Okay, now let's come to solving. To solve indeterminate limits, You can either use rationalization or try cancelling out common factors. Okay, now let's get back to our original question, which was limit as x approaches 2 of x square minus 4 by x minus 2. Here we can simply factor out the numerator as x minus 2 into x plus 2 and then cancel out it with the denominator, which leaves us with x minus 2. And now we can simply use substitution as it's a linear polynomial, and substituting it with 2 gives us 4. Apart from polynomial and rational functions, there also exists limits of trigonometric functions, which we can use standard formulas to evaluate. Now let us discover some of the standard formulas used to evaluate limits. Of x raised to the power n minus a raised to the power n by x minus a as x approaches a is equals to nx raised to the power n minus 1. Limit of sin x by x as x approaches 0 is 1. Limit of 1 minus cos x by x as x approaches 0 is 0. Limit of sin x minus a by x minus a as x approaches a is 1. Limit of tan x by x as x approaches 0 is 0. Alright, now it's your turn. Let's test your understanding. Here is a challenge for you. Use the standard limit formula we just discussed to solve this. Drop your answers in the comments below and I'll be there to guide you. Let's see who can crack this one. So that's everything about limits. In our next videos, we will explore derivatives and L'Hopital's rule. So make sure to like, share and subscribe.